Hello everyone, welcome to my YouTube channel. Today we are going to get a deep dive into wireless sensor networks. Let's start with the basics. Wireless sensor network or WSNS are networks of small smart devices called sensor nodes. These nodes are spread across an area to collect data about physical environment. For example, they might sense temperature, light, vibration, air quality, or pressure. What makes WSN revolutionary is their ability to send this data wirelessly, often without human intervention, directly to a central server or cloud for analysis. In the context of IoT, that is Internet of Things, WSNs serve as the foundation layer. They connect the physical world, things that we want to monitor, and the digital world where the decisions are made. Applications span agriculture, healthcare, smart homes, smart cities, and industry automation. Essentially, any field where real time monitoring and control can improve performance or safety. Moving to the next, let's break down the main process pieces, sensor nodes. These are the heart of a WSN. They include a sensing unit like a temperature sensor or pressure sensor, a microcontroller, a tiny computer that processes sensor data, a communication module, which may be Zigbee or Bluetooth chip to transmit data, a power unit, usually a battery or small solar cell. Their lifespan depends heavily on how energy efficient the system is, often ranging from a few months to several years. Communication protocols. This refers to the wireless standards that the nodes talk to each other or to a gateway. Popular protocols include Zigbee. Zigbee is a low power short range, good for sensor network. Bluetooth. It is common in personal devices. It is suitable for small networks. Wi Fi, which is a higher bandwidth but uses more energy. The choice of protocol affects power use, range, and data capacity. Next comes the gateway. The gateway is the bridge between the WSN and external networks. It collects data from multiple sensor nodes and forwards it, usually via internet, to a central system, that is the server or cloud platform, where the data can be stored, visualized, or acted upon. Then comes the power source. Since many WSN are deployed in places where power isn't easily available, they rely on batteries, solar cells, advanced energy harvesting using vibrations, heat, or light. Power management is crucial because replacing batteries in thousands of nodes can be logistically challenging and costly. WSN can be arranged in different network shapes or topologies which affect how they communicate. These are some topologies. Star topologies. In star topology, all the all the nodes are connected to a central node or gateway. It is simple to implement, and what is the cons is that if the central node fails, the entire system will collapse. Then comes the mesh topology. Mesh topology, nodes connect to multiple neighbor nodes, creating many paths for the data. It is very robust and self-healing. If one node fails, the data will have different route, but it requires more complex routing algorithm and coordination. Next comes the tree topology. It is a hierarchical system where nodes are organized in parent-child relationship, like there is a parent and it have child. It is good for scalability, allows efficient management, but requires careful design to prevent bottlenecks or overload. Last is cluster topology. Nodes are grouped into clusters with the cluster head managing communication for its group. It is extremely energy efficient because data is aggregated before being sent to the gateway, but cluster heads can become performance bottleneck if not well designed. Looking at the key characteristics, for WSN to work well, they need to meet several performance goals. They should be energy efficient because nodes are often battery powered. System needs ultra low power designs to maximize operational lifespan, which includes techniques like duty cycling, no sleep when not needed, energy aware routing, using low power communication protocol. Then comes the scalability. A good WSN should easily handle both large and small networks, from dozens of to thousands of networks, without performance breakdown. Then comes the reliability. Reliability data transmission is essential, especially in critical moments, applications like health or safety monitoring. Ideal system aims for packet loss rates between 1%, less than 1%. Then comes the security, which is the most important part. Since data moves wirelessly, protecting it from eavesdropping or tampering is essential. Common practices include encryption, authentication mechanism, secure key management. So these were the key characteristics. Let's look at the application. These are the environmental monitoring applications, how WSN works in real life, precision agriculture. Farmers deploy soil moisture and temperature sensors to optimize irrigation and fertili- fertilization, which can include the yield by 15 to 20%. It will reduce water waste, and improve sustainability. Then comes the forest fire detection. Sensors detect rising temperatures or smoke levels, providing early warnings before the fire speeds, because it happens that the fire speeds very fastly and it can acquire a whole area between just a moment of time. Studies show that this can cut the damage by up to 60%. Air quality monitoring. Networks of air sensors monitor pollutants like ozone or CO2. This data informs public health alerts and helps government manage environmental regulation. These were the environmental applications. Then get to know the industrial automation application. In factories and industries, WSN powers Industrial Internet of Things, that is IIoT, industrial IoT, predictive maintenance, vibration and temperature sensors attached to machines detect abnormalities before breakdown happens. This reduces unexpected downtime by 30%, saving money and extended equipments. Process control. WSN monitors conditions like pressure or flow rate in industrial processes, enabling the real time optimization. This leads to 10 to 15% efficiency gains. Then comes the asset tracking. Sensors attached to high value asset or inventory help track location, uses, and condition. This reduces losses and improves supply chain transparency by around 25%. Moving to the challenges and future trends. Despite their promise, WSN face challenges. Like every thing has to face some challenges, and they have to work how do they do it in future. Power management. Ongoing researches focus on low power electronics, efficient sleep wake cycles, energy harvesting techniques, because the IoT devices are so, they don't have that much of energy that they could consume, and refreshing the batteries may cause maybe a costly thing. So having power management is the most important challenge in front of IoT. Data security. Security is the most what we can say, devastating threat, because if the data gets leaked, it would cause some the most harm to the system. While raising cyber threats, strong encryption, authentication, and access control are being developed to safeguard sensitive sensor data. Then comes the scalability, which is a future trend for most of the IoT, all of the IoT devices. Large network needs smart solutions for node discovery, automatically recognizing new sensors, that it would be easy to add a sensor to a device, because adding a sensor will has now uh, what we can say, it has been difficult because you have to change the whole, adjust it to the whole system, because if node discovery becomes easy, then it will be very efficient or very easy for the person who is handling that IoT device to add a new sensor. Network management, efficient routing, load balancing, and maintenance. Future trends include AI driven WSN. AI is everywhere, so self optimizing, self healing networks, edge computing, processing data directly at the node to reduce the transmission road. Move to the conclusion. To sum it up, data driven decisions, wireless sensor networks empower industries and government to make smarter, faster, and more informed decisions. What are the ongoing research? Continuous innovation is improving efficiency, security, scalability, and application diversity, making WSN a core enabler or of the future IoT landscape. Thank you so much for watching. If you found this deep dive helpful, please like, subscribe, and turn on the notification for more tech explainers.